Welcome, everyone. You know that feeling when you're staring at a chaotic ECG and it just looks like a jumble of scribbles? Well, you're in the right place. Today, we're going to unlock a simple but honestly a game-changing tool that turns all that confusion into crystal clarity. We're talking about mastering the ECG machine's settings.
Okay, let's just dive right in with a real-world scenario. Your patient's heart is racing, and you get this tracing. What do you see? At first glance, it's a mess, right? The waves are all smashed together. Is it sinus tach, SVT, maybe atrial flutter? Honestly, it is almost impossible to tell for sure because everything is so compressed.
Now, before you start going down a rabbit hole of complex algorithms or immediately calling for a consult, just take a deep breath. The solution is often so much simpler, and it's literally right there on the ECG machine itself. The key is to make the machine work for you, not against you.
That's exactly it. We're not hunting for some rare, obscure diagnosis here. This is all about using the machine's built-in settings as a powerful diagnostic tool. A tool that's going to reveal what's hiding in plain sight. So how do we unsquish those waves? Well, our first tool is adjusting the paper speed. I want you to think of it like the horizontal zoom function for the heart's electrical story.
So this right here, 25 millimeters per second, that's the default setting you'll find on pretty much every ECG machine out there. And it's great. It gives us a consistent way to measure intervals. But as we just saw, when that heart rate gets really high, all those critical waveforms, your P waves, your QRS complexes, your T waves, they just get crammed together, making a real interpretation nearly impossible. And here's the fix. It's so simple. By doubling the paper speed to 50 millimeters per second, we literally stretch the ECG out horizontally. All of a sudden, you can see clear space between the waves. Now, each small square represents half the time, just 0.02 seconds, which gives every single part of the heartbeat room to breathe and show you what it really is. You know, this one adjustment is incredibly powerful. Are there flutter waves hiding in there? Is there a P wave buried inside a T wave? Increasing the speed is your absolute go-to move. It brings those hidden patterns right out of the shadows, and it can turn a totally confusing ECG into a confident, clear diagnosis.
Great. So we've got the horizontal zoom down. Now let's talk about the other dimension, the vertical axis. We can also adjust the amplitude, or what we call the vertical gain. And you guessed it, this is your vertical zoom. The standard setting here is 10 millimeters per millivolt. What does that mean? It means a 1 millivolt electrical signal from the heart creates a wave on the paper that's 10 millimeters or 2 big squares tall. It basically just controls how tall or how short the waves look on the ECG. And just like with speed, we can change this to help us out. So let's say you're dealing with really tiny, low voltage waves. You can double the gain to 20 to magnify them and see them better. Or, on the other hand, if you've got these massive QRS complexes that are so tall they're crashing into the leads above or below them, you can cut that gain in half to shrink them down and get a much clearer picture of the whole thing.
Okay, this is where things get really, really important, because these settings aren't just about making the ECG look neat and tidy, they are absolutely critical for patient safety. Getting this wrong can lead to some really serious diagnostic errors.
So let's walk through a classic and frankly, a pretty dangerous scenario. An ECG tech is dealing with a patient who has huge QRS complexes. So they do the right thing. They reduce the amplitude to make it all fit on the page. But, and this is the crucial part, they forget to mark that change, and you pick up the ECG, assuming it was run at the standard setting.
You're working up the patient, and you decide to check for left ventricular hypertrophy, or LVH. You carefully measure the S wave in V1 and the R wave in V5. You add them up, and you get 20 millimeters. Since the cutoff for LVH is 35, you confidently and completely incorrectly conclude, nope, no LVH here.
But here's the kicker. Since that ECG was recorded at half amplitude, you have to double your measurement. The true voltage wasn't 20, it was actually 40 millimeters. That's well over the diagnostic threshold for LVH. A simple oversight, a missed detail, has just led to a major misdiagnosis.
The most important point here is that this was 100% preventable. This error had nothing to do with not knowing the criteria for LVH. It was all about skipping the very first, most fundamental step of ECG interpretation, checking the calibration.
All right, that was a lot, I know, but let's pull it all together into a really simple, practical toolkit that you can use every single time you pick up an ECG.
I want you to think of these as your 4 go-to controls for any confusing ECG. Is a rhythm too fast? Increase the speed.
Are you looking for a long pause? Decrease the speed. Are the waves too small to see? Increase the amplitude. Are they way too big? Decrease it. It's really that simple.
You know, if you only take one thing away from our chat today, please let it be this. Your first step is always calibration. Before you analyze any rhythm, before you measure a single interval, make it a reflex. Look at the bottom of the ECG and confirm the settings, 25 millimeters per second and 10 millimeters per millivolt.
This one simple habit is what separates the novice from the expert. It is going to protect your patients from totally preventable errors, and it's going to make you a much sharper, more accurate clinician. So let me ask you, the next time you grab an ECG, what is the very first thing you're going to check?